Hi, this is Raza Kayani. Today, I'm going to talk about prefixes and metric system. These two topics, they are mostly used in math, but we are going to apply them in physics. Actually, there is a deep relationship between math and science subjects. Concept of math are applied in all sciences. Math makes physics easy to learn. All types of graphs, practical and experimental work in physics is done by using math. Math observes the trend of the data and helps to plot the graph to reach to a final conclusion. If you learn physics mathematically, you don't need to memorize the concept of physics. You will learn them without memorizing. In other words, we can say that math is a language of physics. Metric system. Measuring system based on the units of length, volume, and mass or weight in power of 10 is known as metric system. The metric system was started during the French Revolution in 1790. Most of the countries in the world use metric system for measurement. The reason for the use of the metric system, other systems, they have a difficult conversion. For example, if you talk about ounce to grams, if you want to convert 1 ounce into grams, so we need a factor to convert. So we need a conversion factor for it. Similarly, to convert from yard to meters, or from miles to kilometers, from inches to millimeters. So it's difficult. But this system is only involved with the power of 10 to convert by multiplying 100, 1,000, 10,000 to convert. So that's easy. We don't need calculator to use. It goes very simple. In this system, we can add prefixes to indicate final answers in multiples of 10. If we see this example, for example, it's a 3.2 times 10 to the power 4 plus this is a 10 to the power 4. That's a 10 to the power 3. We can convert easily. I can change into 0.6 times 10 to the power 4. So we are going to use two rules over here. Number one, when you move the decimal point towards the left, the index number will be positive, and it will be increased by the number of the places moved. So we move the decimal to the left by 1 place, so we can add +1. If we are going to move 2 places, I can add +4. So that's why 10 to the power is 4. Very simple to go. So now I can add up simply this number. So 3.2 plus 0.6, that's going to be 3.8 times 10 to the power 4. Now we are going to see one more example. Since units in the metric system are also based on decimals, they can be easily converted into standard form by moving the decimal point. So here, if I want to change it into standard form, so I'm going to write this number 3.2 times 10 to the power. I'm going to see the points move now. So now I'm going to use the second rule. What is the second rule? When you move the decimal point towards right, the index number of base 10, power of 10, will be negative and increases by the number of the places moved, or we can say number of spaces moved. So I'm going to see how many spaces are there now. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So simply, I can say that -9. Why? When we move to the right, so it's a minus then in that case, according to the rule I have mentioned. So if that's a meter, I can say meter. And we know that 10 to the power minus 9 is a nanometer, so I can write this number as 3.2 times 10 to the power. Oh, I'm not going to write 10 to the power. I simply can say that it's a 3.2 nanometer here, because 10 to the power minus 9 is nano. Metric units are multiples of 10 for conversion. So we can see some more application of this metric system. For example, it's a 10 centimeter. So 1 centi is equal to 10 millimeter. So that's why 6 centimeter can be converted into 10 millimeters directly by multiplying by 10. Now, see another conversion. 1 deci equals to 10 centimeters. Why? I mentioned up here, 1 centimeter is 10 times larger than 1 millimeter. So we can do easy conversion. Now, number 2 here. 1 decimeter is 10 times larger than a centimeter. So 1 deci equals to 10 centimeter. 10 centimeters. So that's why 10 times 46 decimeter is going to be 460 centimeters. Now, number 3, a meter is 10 times larger than a decimeter. So 1 meter equals to 10 decimeter. That's why 34 meter equals to 340 decimeter. And number 4, a kilometer is 1,000 times bigger than a meter. So a kilometer, in 1 kilometer, there are 1,000 meters. So 3 kilometer equals to 3,000 meters. Now we can discuss commonly used prefixes in calculations. Instead of writing 1 million watts, we can write 1,000 kilowatts. Actually, 1,000 watts equals to 1 kilowatt. That's the reason we can convert this big number into kilowatts. Now we are going to see another example. The number 35,600,000 joules can be converted into kilojoules. So again, 3 zeros is 1 kilo. So simply 35,600,000 joules can be written as 35,600 kilojoules. Again, this number can be changed into kilo. Now, 86 million watt can be changed into megawatt. Simply 86 megawatts. The reason $1 million, as a prefix we say mega, equals 1 M. So we can change simply a big number into small in the form of the prefix. Now we can see the application and use of some very big and some extremely small units and prefixes. For example, if you look, hexa, noted by E, the symbol is E. Prefix is hexa, symbol is E, 10 to the power 18. That is 1 quintillion hexabytes. Peta, symbol is P, 10 to the power 15. 1 quadrillion petabytes. tera, T, 10 to the power 12, 1 trillion terabytes. Giga, G, 10 to the power 9, 1 billion gigabytes. Similarly, mega, symbol is M, 10 to the power 6, 1 million. So we are going to see where we use these one number in everyday life. So this megabytes, gigabytes, terabytes, petabytes, exabytes can be used in data transfer in computer, and that is being used as well. So now we are going to see the megabytes. We say megawatts as well for the power of the electricity. Kilo mean 1000, 10 to the power 3. Mass is often measured in kilograms. That is the SI unit of the mass. Hecto, H, 10 to the power 2, that is 100. Deca, DA is a symbol, 10 to the power 1, it's a 10. 10 decipascal. For the unit of the sound waves, we can say decibel. Now we are going to see the small units, okay? They were all big numbers. Now we can see the small in fraction. Deci, denoted by D. In fraction, 1/10. So everyday example, fluids are measured in decimeters. Also for unit decibels. Centi, C, in fraction 1/100, because centi mean 100th part of something. Like centimeter means 100th part of a meter. We know the meter measurement and we can see how big that distance is. So distances are measured in centimeters. Milli means 1000th part of something. 1/1000, 10 to the power -3. So time is measured in milliseconds. Millimeter, milligram. Micro, denote, the symbol is mu, that is Greek letter, 10 to the power -6, because it's 1/1 million, so that can be changed 0.000001. Often used to measure wavelength of electromagnetic waves, very small distance basically. Nano, the symbol is N, 10 to the power 9, used to measure atomic spaces. Very small one, invisible distances. They can be used by using electronic microscope. Pico, the symbol is P, 10 to the power -12. Picogram, picoampere, very, very small numbers. Like if current cannot be measured with the milliamperes, so we can, or microamperes, so we can go further small units, picoamperes. Femto, symbol is F, 10 to the power -15. 1 quadrillionth. Atto, A, 10 to the power -18. 1 quintrillionth, very, very small, like 0 point, we can write it 0 point, then 17 zeros, and then 1, very, very small number in fraction. In this way, as you know, because that is scattered. If it is difficult to memorize all these prefixes as given here. So because they are more scattered, so we can summarize this way. So you can write in your notebook in that form, and that's easy to keep in mind then. So some prefixes, deci, centi, milli, micro, nano, pico, etc., are used with the unit to indicate a fraction of unit, like 1/10, 1/100, 1/1000. So they are really very, very small numbers. Now we are going to see some more conversion. In example 1, how many bytes are there in 5 gigabytes? So we are going to see, we are going to convert into gigabytes. So we know that 1 gigabyte equals to 10 to the power minus 9 bytes, 1 billion bytes. So 5 gigabytes. So we can change 1 giga equals to 10 to the power 9. So we can write in this way. That is a shortcut way to write. Otherwise, we have the other option to write. Yeah, we can add up 9 zeros, okay, this way. That is also option to write. But that's the simple and shortcut way, so we write in this form. Example 2. How many grams are there in a mass of 2.5 kilogram? So first, we are going to change the kilogram into grams. So 2.5 kilogram, we can convert this way easily. 2.5 kilo means 1,000 grams. 1 kilo means 1,000 grams. And simply we can multiply to change into kilograms by using the prefix kilo. Now we can practice this one. How many kilograms are there in a mass of 40 million kilogram? 40 million milligram, sorry. Now we can practice this example. How many kilograms are there in a mass of 40 million milligram? That's the number. So we are going to change into kilograms. So I'm going to start with 40 million milligram. So we know this factor very well, that 1 milligram, 1 milli means 1 milli is 1,000 of something. So that's equal to 1/1000 gram. So I can cross multiply. By cross multiplication here, I can change 1 gram into 1,000 milligram. So according to this conversion, my 1 gram is 1,000 milligram. So here in this number, instead of writing 3 zeros, I can change this 1,000 milli into gram then, okay, because that's 1,000 milligram equals to 1 gram. So I can change this factor into gram. So that will be only 40,000 gram now, according to this conversion. Now I change from milligram to gram. Now I can change from gram to kilogram. So 40,000 gram equals 40 kilogram. Simple. Why? 1,000 gram equals 1 kilogram. So simply we can change into 40 here. Now we are going to see some more example. In an experiment, the wavelength of the single color light is 7,500 times 10 to the power minus 10 meters. Convert this wavelength A into micrometers and B into nanometers. So we are going to change into two things, micrometers and nanometers. So what I'm going to do first, I'm going to break up this one into 10 to the power minus 10 equals 10 to the power minus 4 times 10 to the power minus 6. The reason to break into 10 to the power minus 6, because micro means 10 to the power minus 6. So that breakup I can write over here, and then simply I can change this factor into micrometer. Why? 10 to the power minus 6 is a micrometer. So that's the very simple technique to convert. So that number can be simplified further to 0.75 micrometers. So we have done this one into micrometers. The same number now we are going to change into nanometers. So now I'm going to break up 10 to the power minus 10 in this way, 10 to the power minus 1, and 10 to the power minus 9. The reason to break up in this factor, because nano means 10 to the power minus 9, so that breakup I can write over here, and then what can we do? 10 to the power minus 9 can be written as a nanometers, and we can simplify this factor. That's going to be 750 nanometers. So that's again very simple method to just convert into required unit and prefix. So that's easy way to change into the prefix in a simplified way. Now we can try another example. If you were listening frequency of 3.5 gigahertz on the radio with a wavelength of 750 micrometer, what is the speed of the wavelength? So here, two prefixes are used, gigahertz and micrometer. So we have to change them. The formula for the speed we use, V equals to F lambda. So we can substitute the values here. Now we can change the prefixes. So giga means 1 billion, so 10 to the power 9 hertz, 1 gigahertz, 10 to the power 9 hertz, and micro, 10 to the power minus 6, we can just substitute here. And after simplifying, we can get this result. And we can write in a standard form this way. Now, the decimal we moved, okay, towards left. So the number of the places moved will be a positive. So we move 1, 2, 3, 4, 5, 6 places. So that's going to be a plus 6, 10 to the power 6. Thank you for watching. Subscribe to the channel to receive the notification of the latest topic.